Welcome to the video series about our TEC controller family products. Meerstetter Engineering is a Switzerland-based company specialized in laser diode drivers and TEC controllers for thermoelectric cooling. I would like to give you an overview over the performance categories and present you the main functions of our TEC controllers. But maybe you asked yourself why you should use thermoelectric cooling. The main advantages when using thermoelectric cooling instead of compressor cooling are that there are no vibrations, no acoustic noise, and that they are mostly maintenance-free. TEC modules, also known as Peltier elements, exist in various forms, sizes, and performance categories for a vast number of applications. Therefore, compatible TEC controllers are needed to drive these elements. To begin, I would like to present you the TEC controller product line. Here's a selection of different controllers. Our controllers are available from 1 ampere up to 32 ampere output current at 21 volts and some even at 30 volts, from single to dual channel. This makes them compatible for almost all applications. The latest edition, the TEC-1092, is suitable for small sensor applications as an example. The most powerful variant, the dual-channel controller TEC-1123, offers two independent 16 amps output channels, which can be combined. Cooling of diode-pumped laser diodes or biomedical samples is possible. All controllers have the same functionality, the only difference is the mechanical size and the output power. We are constantly refining the controllers and developing new products. Let's have a closer look at the TEC controllers. What makes them unique and in which points are they different from other controllers on the market? The first difference, in our opinion a quite important one, is the power supply mode for driving the Peltier element. This is a topic which is often not enough taken into account when designing thermoelectric applications. I would like to stress the disadvantages of PWM and advantages of DC current. To visualize this, we compared a Meerstetter Engineering DC current TEC controller against a PWM output TEC controller available on the market. We made the following experiment. As a target temperature for a 1 watt load as an object to be cooled, we chose in both cases 10 degrees Celsius in an ambient temperature of 24.5 degrees Celsius. Both controllers fulfill the same need, but in terms of efficiency the difference is quite striking. The power needed to cool down the object down to 10 degrees Celsius was in case of the PWM controller more than 6 times more, 56 watt versus 9 watt. The heatsink temperature in the case of the PWM controller was 5 degrees Celsius higher. This can lead to a higher temperature in the thermoelectric cooling system, especially when it's enclosed in a case. The waste heat is one of the main cost factors when designing thermoelectric applications. In other words, the total amount of heat to be dissipated of the system using a PWM controller was more than 4 times larger. Hence, a much bigger heatsink would be used in case of a PWM controller. A more efficient system allows the usage of smaller components, like for example power supply and heatsink. The conclusion is that Peltier elements controlled by PWM are less efficient than those driven by DC current. PWM control can cause interferences and noise in the system and in the object or device to be cooled. This is especially problematic when the cooling of highly sensitive devices is needed. Examples are CCD sensors, cooling of reference light sources, laser diodes for measurements, and so on. Also, manufacturers of Peltier elements advise against the usage of PWM because of the worse performance. Stability of the temperature is crucial in several applications. Our TEC controllers have a typical measurement precision of 0.005 degrees Celsius when using 4-wire measurement technique and PT100 sensors. The temperature can be measured in a wide range from -50 up to 200 degrees Celsius. Due to the compact size, integrated cooling baseplate and mounting options, the controllers are ideally suitable for the integration into a bigger system. Now let's check out the main functions of the TEC controllers. A very handy tool is our service software, which is included in the price of the controllers. The software allows the configuration of the controller, optimization, monitoring of the cooling application, as well as error management. The temperature graph, for example, provides you valuable information about the behavior of the thermoelectric system. As you can see, by using our software, the evaluation and implementation is really simplified. Depending on the thermal load, the PID controller has to be optimized for an optimum performance. Using the software built-in auto-tuning function, this is possible in a straightforward manner. This function tries to find optimal values for the controller by measuring the characteristics of the thermoelectric system. Of course, the individual PID parameters can be tuned manually as well. Our TEC controllers support different modes of communication, allowing configuration, control and monitoring. Communication is possible over USB to connect the PC or over RS485 for the communication with other devices. Our devices can be controlled using our open serial communication protocol, and we provide an API. This allows the simple implementation of the controller into a bigger system. All TEC controllers have a connector providing digital signals. They can be used as general-purpose I/O and for predefined status indicators. Another possibility is our display kit DPI1113 for instant status information, debugging and feedback. The TEC controllers offer multiple modes to keep an object at a constant temperature, like heat only, cool only, and operation in both directions. The bipolar current source allows switching between heating and cooling without any mechanical modifications or wiring changes. And there is even a fan control feature to cool the heatsink by ventilation. Applications like thermal cyclers, also known as PCR machines, require repeatedly changing temperature levels or predefined temperature profiles. Our controllers provide means for thermal cycling using lookup tables and scripting. Like the normal temperature controlling functionality of the TEC controller, the scripting function allows standalone operation of the cooling system without the need of a PC or any other external controller. Detailed information about thermal design you can find in the compendium section on our website. The following videos in this series explain the necessary steps to set up a TEC controller. Please refer to the product pages of the TEC controllers for more information. Don't hesitate to contact us for customized solutions and detailed information about our products. Thanks for watching and enjoy the other videos.